This section we're going to look at compound interest. Compound interest is one of my favorite financial concepts because when we compare it to simple interest, we get that simple interest is calculated once for the period of the loan or the investment. As we saw before, the formula for simple interest is I equals PRT, whereas compound interest is computed on the principal and any accumulated interest. So if you invest in something that gets compounded with its interest, your money makes money by getting interest, and then you get interest on your money plus your interest. So the money that you made actually makes more money. It's a cool concept. So before we get into this, we're first going to look at one more concept dealing with simple interest that is kind of pertinent, and we're going to see it used in a few examples. And so we had talked about simple interest as I being the interest equals the principal times the rate times the time. Okay? But that doesn't tell us the total amount owed, it just tells us the interest. So to figure out the total amount accumulated or owed, depending on which end of the deal you're on, we're going to represent that amount as A. And A is going to be equal to the principal plus the interest. So if you loaned money with simple interest and somebody was going to pay it back to you, you wouldn't just get the interest back, you would also get the interest plus the principal. But interest, we know, is equal to the principal times the rate times the time. This good old formula that we have up here. So, using an algebraic concept that you might not have seen for a while, but it's called the distributive property, both terms here have a P, principal. So what we can do is we can actually use the distributive property in reverse and do what we call factor, or pull out the common term from both P and PRT. So essentially what I'm doing is I'm dividing out the P and pulling it outside of these two terms. So when we do that, we pull out the P, and then we have to think about what would remain here. So essentially I'm saying I'm going to pull out this P, so I'm going to divide P by P. P divided by P is equal to 1, plus PRT divided by P is equal to RT. So if I want to figure out what the actual total amount is from a simple interest problem, we would take the principal times 1 plus the rate times time. Okay? So we're going to see how this plays out in an example. We are going to consider two separate accounts. Account A, we're going to invest $100 at an interest rate of 10%, simple interest, and that's going to be the annual interest rate. Now, I will note that 10% is a very high interest rate, but we're using it in this example because it's a nice value to calculate. Okay? For account B, we have $100, so same principal, invested at 10% interest compounded once a year. So we're going to look at these two different accounts and see what happens. At the end of year 1, we're going to look at account A. Okay, and we're going to figure out how much interest it has, and we're also going to figure out how much total amount would be in that account. Okay, so I equals PRT, well that's going to be 100 times 10%, or 0.1, times the time, which is equal to $10. Okay, so the amount in account A would be 100 plus 10, which is $110. Okay, so the $10 is the interest, and the $110 is the amount in the account at the end of year 1. Now for account B, it's 1 year. We're starting with the same amount, And we're going to treat this like it is simple interest. So the principal is $100, the rate is 10%, and the time is 1 year. So now we get that the interest rate was $10 and the amount in the account A would be $100 plus $10, which is $110. So at the end of the first year, they have the same amount in their accounts. But at year 2, something interesting is going to happen. At the end of year 2, for the account A, okay, we're going to have our principal is $100, our rate is 0.1, and our time is equal to 2 years. So the amount of interest is going to be $20. And so the total amount in account A at the end of 2 years would be 100 plus 20 equals $120. But account B is different because account B accumulates interest on the previous principal plus interest. So for this one, we're not starting from the beginning like in the simple interest example. We're actually going to look up, okay, well, at the end of year 1, our principal wasn't $100 anymore. Our principal would now be $110 times our interest rate, which is 0.1, times 1 year, because we're going to go 1 year past after the first year. So we get here that our interest on this account equals $11. We add that to the original amount from this time period, so 110, what we started with at the beginning of year 2, technically, so end of year 1, beginning of year 2, plus the $11, and in this account, we have $121. So this process continues. And we can see at the end of year 3, our account A would end up having $130, and our account B would end up having $133.10. So as this continues, you can fill out the rest of the chart to see how much more bank account or whatever account B has than account A when we're compounding everything each year. So, which account will have more at the end of year 5? Well, if it follows this pattern using some inductive reasoning, we could say that account B will have more at the end of the 5th year. Does the balance in account A increase by a constant amount? Well, it increases each year by $10. The first year, after year 1, we had 110. After year 2, we would have had 120. After year 3, we would have 130. So we could assume that after year 4, we'd have 140. And after year 5, we'd have 150. So the balance in account A does increase at a constant by a constant amount. However, for account B, we saw an increase by 10, an increase by 11, an increase by $12.10. So we have increases to the balance in account B by a not constant amount. This amount is actually increasing. So we're going to use that formula we looked at for simple interest earlier to figure out the amount in account A after 50 years. So the amount accumulated in the balance for account A after 50 years, well, our principal was $100 times 1 plus the rate, 0.1, times 50. We can type this out in our scientific calculator to get the result. Make sure you put correct parentheses around this part that I'm kind of bolding. And we end up getting that the amount in account A after 50 years would be $600. This should make sense because at each year we're getting $10 more, okay? 50 times 10 is 500 plus the original amount 100. 100 plus 500 is 600 if you want to kind of check your work. But let's make a prediction about the balance in account B after 50 years. Take a couple seconds to think about it, and think about how much do you think will be in account B after 50 years? Is it going to be greater than 600? We might feel that way because of what we saw in even just the first 3 years. But how much more do you think it's going to be? Do you think it's going to be at $700? Do you think it's going to be at $1,000? Do you think it's going to be at $1 million? Think about it and write down a prediction. It's a prediction, so it's okay if we end up not being right. No one's going to see it because we're not meeting in class. So go ahead and write down your prediction. Now, we're going to figure out in the next part how we can actually calculate the exact amount for account B in 50 years.